Today we are doing lesson 10.5, extension simulations. In order to complete your notes for today, you will need a die and a coin. So before you watch this video, you're going to need to go find those things, or you will need to go to a website such as the one I have listed on the slide, random.org, where you can get a coin flipper and a dice roller. So go ahead and pause the video and get your die and your coin ready to go. Okay, so let's go ahead and take a look at some simulations. Our essential question for the activity here is, how can you use a simulation to find a probability? So a simulation is something that you do, like flipping a coin or rolling a die, that stands or represents for something that's a real world situation. Up to now, we've looked at probability for coins and dice, among other things. If I roll a die, what's the probability of getting an even number, things like that. But this, for today, when we're rolling a die, it's not representing just rolling a die. It's representing something else in a real world situation. So here's the first thing that you're going to be doing for your simulation. It says a cereal company is having a contest. To win a prize, you must collect 6 different cards that spell "you win." One of the 6 letters is put into each cereal box. The letters are divided equally among the boxes. How many boxes do you think you'll have to buy to collect all 6 cards? Go ahead and pause and write down your answer. All right, now we're going to do the simulation to see if your prediction is right. Since there are 6 different cards that are evenly distributed, you can use a number cube to simulate collecting the letters. Each of the numbers from 1 through 6 will represent a letter. A roll of the number cube will simulate buying 1 box of cereal, and the number rolled will represent the letter inside that box. Roll the number cube and keep track of the numbers you roll. Continue to roll the number cube until you've rolled every number at least once. Once you have finished that, so you're going to go ahead and roll in just a minute, and you're going to put tally marks to record how many you got for each one. And then you can write, or you can type in your answers for how many you got for each one. Once you have at least one in each thing, then you can stop and answer the questions at the bottom. So you'll answer, what was your last number rolled? How did you know? How many rolls did it take to get all 6 numbers in your simulation? And how many boxes of cereal do you think you would have to buy to get all 6 letters? If you bought this many boxes, would you be sure to win? And explain. So go ahead and pause the video and try the simulation. Okay, let's talk about our results. So you should have how many times it took you to roll different things. You should have written down what your last number was. How do you know? Well, that's the last one that you saw, or that might be the only one where it had 1, and the other ones might have had more than 1 as an option. How many rolls did it take? Well, everybody's numbers here is going to be different, so I'm not going to write down any example for you, but you should have yours recorded however many rolls it took in total. Sometimes for people it's 6 or 7. Sometimes for people it's like 15. It can vary quite a lot. So make sure that you've recorded how many rolls it took. And then how many boxes of cereal do you think it would take to buy to get all 6 letters? If you bought this many boxes, would you be sure to win? Well, for this one, let's say it took me 10 times to get at least 1 for each letter. So I go to the store and I bought 10 boxes. Am I definitely going to win? No, not necessarily. I could get only Y's and U's. It's all up to chance. But giving that simulation and looking at my result, that gives me a good idea of how likely it is if 10 could let me win. Yeah, well, it happened. So that's definitely a possibility. All right, so let's go ahead and take a look at our next activity. This one has to do with our coin flip. And I'm going to get you started on it, and then you're going to finish it on your own. So your results are going to be different than everybody else's and different than mine. So I'm not going to write down all my results for you, but we will get it started. Okay, so for this situation, this activity, it says you write a 4-question survey. Each question has a yes or no answer. You have your friend answer your survey. Okay, we're not actually writing surveys. This is just the situation that we're simulating. Design a simulation that you can use to model the answers. Use a coin in your simulation. Do 10 trials. Okay, so I'm going to say heads means yes, and tails means no. For each trial, I'm going to flip the coin 4 times. That's because it's a 4-question survey. All right, so I'm going to flip a coin, and the first thing I got was a heads. Now, you're not writing it down because your results are going to be different. I'm just modeling for you what you are going to do. Okay, I'm going to flip another coin. I got a tails. I flipped another coin. I got a tails. And I flipped another coin. I got a heads. So that's my first trial. Then I'm going to go to my next trial. So I'm going to flip a coin. Again, you're not writing this down. You're going to be writing down your own results. I got a heads. Flip a coin, I got a heads again. Flip a coin, I got a tails. And then I got a heads. So you're going to do that. You're going to do 10 trials. Each one's going to have 4 letters that you are going to write in your box or type in your box. And then you're going to find the experimental probability that your friend answers yes for all 4 questions. So yes for heads means that you have heads, all 4 being heads. So right now, if I was going to do my experimental probability based on this, I would say it's 0 out of 2 that I've gotten all heads. But you're going to do it 10 times, and you're going to see how many times you get all 4 being heads. Okay, so go ahead and pause the video and conduct your simulation, and then answer question B when you're done. Go ahead and pause the video and try your simulation. Okay, so if I'm going to just do a couple more. Again, you're not writing mine. You should have yours written down. If you don't have yours down yet, then go ahead and do them. All right, so here are my results for the first 5. For time's sake, I'm only going to do 5, but you should have 10 there. Out of my 5, I had 1 out of 5 that was all yeses. You will count for yours how many you had. 1 out of 5 simplifies to 20. Well, it's already in simplest form, but the percent is 20%. For your experiment, you're going to count how many times it was all heads out of your 10, so it'll be something over 10, and then you'll make it into a percent. Okay. Let's go ahead and take a look at the next part. So our I can statement for today, I can design and use a simulation to generate frequencies for compound events. All right, so let's take a look at this next situation. A couple plans on having 3 children. The gender of each child is equally likely. A, design a simulation involving 20 trials that you can use to model the genders of the children. B, use your simulation to find the experimental probability that all 3 children are boys. Okay, so we are going to start by designing our simulation. We're going to use a coin because that has 2 equally likely situations. So we're going to use a coin. Our simulation is we're going to flip a coin. We're going to say heads equals, I'll do boy, and tails equals girl. So you are going to do each one. There are 3 children. So for each one of these 20 trials, you're going to flip your coin 3 times and record what you have. I'm going to give you some examples. You're not going to write mine down because you're going to do your own simulation. Okay, so I'm flipping my coin. I got a heads, I got a tails, and then I got a tails. Then I got a heads, and a heads, and a tails. Then I got a tails, and a heads, and a tails. Then I got a tails, and a tails, and a tails. Then I got a tails, and a heads, and a tails. Okay, so you are going to do something similar. You're going to flip your coin. You're going to record your results. And then you're going to find the experimental probability that all 3 children are boys. So out of 20, you're going to see how many times you got all 3 boys. And we said heads was going to be boys. Okay, go ahead and pause the video, conduct your simulation, and write down your results. Okay, so let's double check to make sure we did the experimental probability right. All right, so I'm going to just make up a few more results here. You have your own results, so they're going to look a little different than mine. And I'm only going to do 10. Okay, all 3 children are boys. So I have 3 heads here, and that's it. So mine would be 1 out of 10, or 10%. Yours is going to be out of 20, however many times you got all 3 heads. So double check, make sure you have your probability written down, the number of times that you got all 3 heads out of 20. All right, let's take a look at how we can use a random number generator to help us with simulations. So depending on the situation, sometimes it is not practical to be flipping coins or rolling dice. So we can use random numbers to help us with different simulation situations as well. So in this example, it says there is a 60% chance of rain on Monday and a 20% chance of rain on Tuesday. Design and use a simulation involving 50 randomly generated numbers to find the experimental probability that it will rain on both days. All right, so 60% is like 6 out of 10. And the 10 is going to be our 10 different digits from 1 through 10. And we're going to use 0 to represent our 10s. So for 60%, we're going to call that first digit, which will be our 10s place, needs to be 1 through 6. 6 numbers out of 10. And then for our second digit, so that would be our 1s place, we're going to have it between 1 and 2. Okay, so we've got a list of 50 randomly generated numbers. Let's find the probability it's going to rain on both days. So I'm looking for numbers that have the first digit 1 through 6 and the second digit a 1 or a 2. All right, so let's see. Nope, 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 nope. So nothing in the first row works. Let's take a look at the next row, and we're going to circle anything that works. No, 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 no. Nothing in the second row works. Let's look at the third row. No, 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 no. Nothing in that row works. All right, let's look at the fourth row. No, 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 yes. 21 works, so I'm going to circle it. It has the first digit, 1 through 6, and the second digit is a 1 or a 2. Now this next one is a 1. It's like the first digit is a 0. It really only has a 1s place. It doesn't have a 10s place. So we look at that as being 0, 1. So that doesn't work. Okay, we're going to continue on. No. Yes, 41 will work. First digit is between 1 through 6. The second digit is 1 through 2. No, no, no. All right, let's look at our next row. 21 works. Okay, let's look at our next one. We have 41. We have 42. No, no. Okay, and our next row. Nope. Our next row. Nope. And our last row. No. So now we count up what we have. 1, 2, 3, 4, 5. My experimental probability is 5 out of 50. And then simplest form, fraction, and percent, just like all our probability ones. 1/10, which is 10%. That is my experimental probability that it's going to rain on both days. All right. Go ahead and let's take a look at this one. You're going to be trying it on your own, but I'm going to help you get it started. So for this problem, it says there's a 40% chance of rain on Wednesday and a 20% chance of rain on Thursday. Design and use a simulation involving 50 randomly generated numbers to find the experimental probability that it will rain on both days. All right, so Wednesday comes first. I'm going to call my first digit. I don't know what I'm doing here. Okay, so first digit is going to be 1 through 4. And our second digit for Thursday is going to be 1 or 2. Okay, you are going to use the 50 numbers selected here. You're going to go ahead and read through them. And you are going to write down when you see ones that work. And then once you're done, you're going to find the experimental probability. Go ahead and pause the video and try that on your own. Okay, let's check our work. So we are looking for digits 1 through 4 and 1 and 2. Remember, if there's a 1-digit number, that's like that first digit is 0. So that doesn't work. This one does, 32 and 12. Okay, and this one, I have 22. Nothing in that row. 41. Oh no. 1 through 4, nope. And then in that one, nope. 12. 12 works. No. Okay, so I have 1, 2, 3, 4, 5 again. 5 out of 50, 1/10, 10%. All right, let's try our next one. Each school year, there is a 50% chance that the weather causes 1 or more days of school to be canceled. Design and use a simulation involving 50 randomly generated numbers to find the experimental probability that the weather will cause school to be canceled in at least 3 of the next 4 school years. So we're going to do 4 numbers for the 4 school years. We're looking for ones where at least 3 indicate that the weather's changed. For 50%, we're going to do 1 through 5. All right, so we need 3 of the 4 that are in the numbers 1 through 5. It doesn't have to be the first 3, but at least 3 of the 4 are the numbers 1 through 5. All right, so let's start this look together. So, nope, I only have 2 that are 1 through 5, 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 2 that are 1 through 5. Nothing in the first row works. This one does. 1,219 has 1, 2, 3 numbers between 1 and 5. This one works. 3,404 has 3 numbers, 3, 4, 4, in between 1 and 5. This one works. Again, 3 numbers, 2, 1, 5, from 1 to 5. No, and this one, yes. Okay, go ahead and pause the video and finish circling the rest of the numbers that work for the situation. Okay, let's check our answers. So, looks like this one works. This one. This one. This one has all 4 that work. No. Remember, 0 does not count as being 1 through 5. No, nothing in that one. This one, yes, all 4 are 1 through 5. This one, yes. This one, yes. This, oh no, 6 is not 1 through 5. Almost got me tricked. Nope, that has 2. This one works. This one works. Nope. Yes to that. Okay, this one works. That one works. And then in our last row, no, this one. All right, so let's count up how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I have 17 out of 50. That is already simplest form. That's going to be 34%. All right, let's take a look at this one. This is our last one. Oops. You make about 60% of your free throws. Design and use a simulation involving 50 randomly generated numbers to find the experimental probability you will make at least 2 of your next 3 free throws. Go ahead and pause the video and do this one on your own. Okay, let's check our answer. 60% means we are going to be looking for the numbers 1 through 6. We need at least 2 of the next 3. All right, so we're looking 1 through 6, 2 of the next 3. Okay, this one happened to have all 3 1 through 6, as does this one. This one has 2 1 through 6. No, no. No, yes. Yes. No. Yes. Let's see. No. No. 2 of them. Yes. No. Yes. No. Yes. Yes. No. Yes. All right, let's see. No. Yes. Yes. Remember that 0 doesn't count as being from 1 through 6. But the 6 and the 3 do. We need at least 2. No, no. Yes. 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 Yes, everyone in that row worked. No, this has a 4, but again, that 0 doesn't count from 1 to 6. Yes here. Yes here. Yes here. No. Yes. Yes. No. 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 Yes. Yes. No. Yes. Yes, last row. Yes. 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 No. Yes. Oof, I've got a lot of things circled. Let's go back and double count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Whew. Okay, so that one was 31 out of 50, which is 62%.